So lab one for physics two, where we're going to be going through the charge tape lab. This is a lab where you're going to be getting two pieces of tape and pulling them across each other. So you're going to be able to see the charge interaction between the two pieces of tape. The first half of the lab, you're going to do physical experimentation so that you can figure out um, basically a general assumption. Using assumptions, you're able to calculate what the expected value of charge in each piece of tape is. Um, and the second half, you're going to be using that data that you've collected from the physical experiment and trying to apply it to a computer model to simulate how these charge tapes could interact. One of the important things for this is calculating the difference in coulombs between the two pieces of tape, which is what we're going to go through with some physics concepts, and how error could be affecting both models or just how we're contributing it to the experiment. Physics concepts that we're going through in this, there's going to be a lot of interaction with the electrical field and the gravitational field, since they'll have like different directions. So you're going to be able to tell the charge of both the pieces of tape by their distance. As you can see in the bottom, there's the equation for Coulomb's law, so you're going to be able to see based on the distance between the two objects about what you'd expect each of the charges to be. So once you pull the piece of tape off, it's going to be like after it's placed on top of another piece of tape, it's going to be pulling electrons off with it and making one of the pieces of tape, the tape that you pull off, more negative because it's leaving with the negative charge of the electrons. So basically, we're going to be able to suspend the. Actually, I've moved my slides around, but this is the glow scripts of how I've been modeling it for the computational model, and basically how I modeled it through glow scripts and incorporated the physical data that I collected through the lab to make a glow scripts model. So this is what I got through the results of glow scripts. I was able to tell the newtons from gravity and the newtons from electric force based on the weight of the piece of tape, and um, due to the opposing forces, you're able to tell net electric force on tape A due to tape B, which is held below it. The electric field at tape B due to tape A in the y direction, and the electric field at tape A due to at tape A due to tape B, in which direction. So then this is what the model calculated as the charge of the tape B in coulombs. So this is how the procedure of the lab worked out. By taping one piece of tape to another in the bottom left figure, you're able to see once you pull it off, it pulls electrons with it, just based on the static interaction and electrostatic interaction. And then once they're separated, you can suspend the tape that is left on the table by by two some basically you're suspending it and you're able to take tape A and put it by tape B and be able to move it and see where the forces equal out. So at that distance, you'll be able to have a better idea of where to collect the data. I mean, like what data is the most useful at that point. This is the experimental data we've been able to get. Weight of the tape, length, width, distance between the two pieces. And here's the calculations we did where it's the force gravitational and the magnitudes of both of them equal out, where the tape will be freely floating. The electrostatic force and the gravitational force. So we were able to tell that the Q was that. And basically, we're calculating the amount of electrons that would have had to be required to have this amount of electrostatic force on the, well, how much um, charge that would inflict, that would make this amount of force to balance out the force of gravitation. So we did have a little bit of differences in the simulation and the physical. In the experiment, we calculated as negative 1.84 times 10 to the negative ninth coulombs. Our simulation showed negative 1.857 times 10 to the negative ninth coulombs, which are pretty similar numbers, but with how the model does it and how we physically did it, we basically made it with the assumption that there's no air resistance and that the tape was basically a point mass because it would be a lot more complex integrals um, for solving it as exactly where all the electrons are spaced out on the tape. So that's why I believe there's a small discrepancy in the both the models.